Hi everyone, it's time for another video. This video is going to be about a thing that we call conditionals, as you can see on the screen there. It's me, your friendly host, Pippin. And conditionals are a great thing for us to learn. They're another huge part of how we get our programs to kind of actually respond to things that are happening. So we've seen how variables let our programs change over time and do things potentially randomly or very predictably. Conditionals is how we get our programs to react differently depending on what's happening in the program at that time. So it's a huge part of how we do anything interactive, for example, or have our program react. So it's a big deal, and it's a really good one to master. So back to the screen, of course. Since I'm starting a new series of videos here about conditionals, I'm going to go ahead and start a new project. So I'm going to go over to the course website, which I hope is like that, and I'm going to go download the template and do the usual stuff. So I'm just still putting this in the videos. You can obviously skip ahead if you want to, because you've seen me do this a few times. But I'm downloading the template zip file. I've set this to download to my desktop these days. I thought that was a bit more sensible. Oh, that doesn't do anything because I haven't set it up. That's annoying. And I'm going to go to my desktop. There's my desktop right there. You can see the zip file there. I'll open it up. And I'm also going to want a window with, obviously you'll be doing this however you do these things on your computer. But in my documents, GitHub, there's my course repository, good old cart253, and I'm throwing this into my experiments folder because that's where I've decided I'm going to put my sort of class time experiments, and I will drag that folder in here, and I'll call it conditionals. That looked like it had a spelling mistake, conditionals experiments. So now I've got a place that I can work on the kinds of things we're talking about today. And as is traditional, I will also open up GitHub Desktop. And I'll make a sort of at least an opening commit of all of these files that got added. So started experimenting with conditionals. It's not a new kind of drug, although maybe it could be very addictive, but that's not actually funny. Conditionals are, however, very fun to play with. I can tell you that much. Okay, so I've committed that, and I'm pushing it to the website so that it's everywhere, which is perfect. And now, of course, I want to open up Atom. You can see that it's automatically opening my previous set of experiments, which was with variables. I will close that one, and I will instead open, if I drop back here to cart253, and I go to experiments, and then we have conditionals experiments. That's the one I want to open. And as always, remember, we want to open the folder that contains all of the project, not an earlier folder and not a file in the project. Pow. Okay, get my script open. So, conditionals. Let's begin. And I'm just going to remove the commenting here, not because commenting is bad, it certainly isn't, but just so that you can see my screen a little bit clearer. Let's begin by just quickly throwing in the whole moving circle idea. So I'm just going to type it in here. I don't know if this is a terrible idea, but I'm just typing in the basic idea of an object that represents a circle and also a variable that keeps track of what the background shade should be set to, and then the circle kind of moves across the screen. I could have copied and pasted this from my lecture notes, but for some reason I'm sitting here typing it all in, and that's okay. You can watch me typing. So my point here is just to get to a thing that we are familiar with. So we add the circle's speed to its x position. Each time we do that, because its speed is 1, it moves 1 pixel to the right. And because that's inside the draw loop, that's happening once per frame, and so it moves along the screen at a fixed rate. And then, of course, I have to draw it if I actually want to see anything. So that's our little program there. a circle that moves across the screen. To make sure that that works, you would go to Packages, Atom Live Server, Start Server. You'll also notice that there's this keyboard command. I'm going to start using that because that's how I usually actually work. So it's Control-Option-L. On a Mac, it's probably Control-Alt-L on a Windows machine. So I hit the keyboard command, and then we have our little project, right? And we see the circle moving along, and this is through the magic of variables. So that's great. We're very, very happy with this. It's a wonderful circle. We know that we could make the circle do some unpredictable stuff if we used random numbers for its speed or its position, for example. But it's still very predictable. The circle just moves to the right, and it's got no real way of changing what it does. It can't change its mind. And so what we really want with programs, if we're going to have them be interesting, is that different things could happen depending on what's going on. The most obvious example of that is just that different things happen depending on what the person using our program does, if we're making an interactive program, which is often the most interesting kind of program. But there are other things that it could react to, from the weather to the current time. Is it Christmas? Should I be playing Jingle Bells? All kinds of things that our programs could potentially react to, but we need a way of talking to the program and telling it to make those decisions. So a quick refresher on what a decision looks like, right? And I'm going to pop over to my text editor as the title of the course, so we can get rid of that. So when I'm making a decision, and I'm just going to steal the example from the lecture notes so I don't say something silly. We make decisions, we often say something like this, right? If there is freezing rain today, so this is how part of how we make a decision is we need to take what we're going to kind of make a decision about. Then good grief, thanks Auto, whatever that was. Then I am going to stay at home. That's how we make a decision, right? There's the thing that we're making a decision about, and there's the thing that we actually do, that we decide to do. And we can look at some of the key pieces of this, right? So there's the thing where we say if. So if there is freezing rain today. This is the condition of our decision. This is the thing that we need to check. If it's true, then we're going to take an action. And if it's false, then we're not. So if there is freezing rain today, if it's true, that's when I'm going to actually act on my decision. If there's not freezing rain, none of this matters. Okay? It's all just hypothetical. The second part of it, after this sort of the condition that we need to check on, is this then bit. Then I am going to stay at home. That's the thing I'm going to do in response if I do make this decision. So if the condition is true, if there is freezing rain, then what I'm going to do, my action is that I'm going to stay at home. And how nice that would be. Although these days I feel like I'm just at home all the time anyway. So computers can make these kinds of decisions, not necessarily about freezing rain, and certainly very few computers can decide whether or not they're going to stay at home. They don't have a lot of choice in the matter. But computers can make decisions about all kinds of things, and in very much the same kind of way. Exactly the same kind of structure, actually. So they say, if something is true, then I'm going to do this particular response, this particular action. I'm going to execute this particular code, right? The trick is, the biggest trick of all, really, is that this thing here, this condition, the kind of thing that we're checking, is it true? On a computer, that's very often going to be to do with maths, because those are the sorts of things that a computer can consider to be absolutely true or absolutely false. They're not like humans who, I guess, have a lot more room for kind of gray areas or philosophy or art or whatever, right? So let's think about our circle, right? One thing that might be nice is if our circle could react to reaching the far right-hand side of the screen. Because right now, if I reload it and we watch its painfully slow progress across the screen, it's moving along left to right. It reaches the right-hand side of the screen and doesn't care. It just goes off to wherever it is that circles go when we can't see them. What if it could respond to reaching the right-hand side of the screen? What if it could make a decision about that moment in time, and it could go back the other way? So returning to this kind of decision thing, what would it be that the circle would ask in order to do something? So what we want to say is, the circle would think something like, if I have gone past the right side of the canvas, then what could it do? Well, then maybe the obvious thing is it could do is then I will turn around and go left. So that's what the circle, we could imagine the circle thinking. If I've gone past the right-hand side of the canvas, i.e. I've gone all the way over to the right, then I'm going to turn around and go to the left. And the effect of that would be kind of like bouncing off the right-hand side. But this is still kind of written in human sort of terms, right? This condition here, this is still the sort of thing that I would be able to think as a person, but a computer, you can't just write something like this. You can't ask the computer to work out what this means. And so we need a kind of mathematical expression. So how does the circle know if it has gone past the right-hand side of the canvas? Well, we know that one thing that is implicated here is the circle's position. So we know that the circle's position horizontally is circle.x. So that's going to be part of it. And then how do we know that circle.x has gone past the right-hand side of the canvas? Well, the right-hand side of the canvas, we know that its position is at the width of the canvas. So if the circle's x position is larger than the width, then that would be the situation where the circle has gone past the right-hand side. So if circle.x is greater than width is the way that we can express this in mathematics. Okay? And then it's going to have to do something here as well, and we'll return to that. Okay? So let's go and write an if statement that actually does this. So we'll go back to our code. So here is where our circle changes its x position, not exposition, which is a word. If we're going to check something to do with its x position, I think it makes the most sense to check it after we've changed the x position, right? You could check beforehand as well if you wanted to, but I think it's going to make the most sense that you check it after it's just changed, because that's when something might have changed that's relevant. So the way that we write this in programming is decently close to how we might think about it, writing it in sort of a human language. So we use this word if, then the condition, the thing that we're going to check, is written in parentheses like this, so these curved brackets, and this is where we write that mathematical equation, right? If circle.x is greater than width. We know that width is the width of the canvas, circle.x is the current position of our circle, and if our current position of our circle becomes larger than the width, it exceeds it, then that's when we know that the circle has gone off the right-hand side. So we write if, then the condition that we're checking, the question that we're asking inside our parentheses, and then in order to tell it what we're going to do, should this work out to be true, we put some code inside curly brackets. And curly brackets like this, this is called a block of code. So something inside curly brackets is a block of code. Okay? And this is where we need to say what we will do if this is true. So only if this is true. If this is false, we're not going to do anything because we don't need to make the decision. If this is true, that's when we want to respond. So how can we make the circle go back to the left? Well, the answer to that, well, there's various ways that we could do this, right? We could say speed equals -1. That would make our circle go backwards because -1 will be then added in the next time through to the circle's position, and that will make its position start going down, and that will make it move to the left. It would be better, though, not to use a number here, since we already have a number that deals with how fast the circle is supposed to move, which is its speed property. So actually the right thing to do here, or a good thing to do here, is to say what we want is to set the circle speed to be the negative version of its speed. So circle speed was 1 when it was moving to the right, which is when this happens. And then in reaction, we're going to set it to the negative of what it was, which is -1. So its speed becomes -1, and it starts to move to the left. Okay, so let's save that and make sure that it works. Circle's moving across to the right. Its x is not greater than the width. It reaches the far right-hand side of the canvas. Its x is greater than width, and so its speed gets set to the negative of itself. It starts moving left, and off it goes. Because there is no if statement telling it what to do when it reaches the left-hand side of the canvas, as you can see, it just blithely continues on. It doesn't know anything about the left-hand side of the canvas, so it just keeps moving. Okay, so you can imagine that if statement's happening, it's being checked every single frame. So it's checking, is it greater than the width? Is it greater than the width? No, 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 yes. And that moment where it is greater than the width is when its speed changes to the negative and it starts moving back to the left. It's still checking whether or not its position is greater than the width on the way back as well, right? And it's always false because it's moving away from the width of the canvas back to the left. So this if statement here, even once the circle has started moving left, back away from the right-hand side, it's still doing this, it's just it's always false because the circle is now moving in the opposite direction. Okay? So that is literally it. You know, this is how we make decisions in programming. It's with these if statements. We write if, and then inside parentheses, remember the parentheses, they're easy to forget, we write some kind of often mathematical expression that's kind of like a question, right? Is circle x's position, circle.x, greater than the width? And if the answer to this is yes, which we would normally call true, if this is true, then we take the action listed inside the curly brackets, the block of code, which is this instruction here in this case, reverse the speed of the circle. Okay? So that is now lovely, and that's making a decision about what's happening in terms of the circle's x position. That is how conditionals work. That is how if statements work. There is literally nothing more to them than that. Well, there's a few more things, and I'll talk about those. But that is really most of what there is to say. I will just point out, and I'll just write this. I'll just write this down here for the moment, here at the bottom of the screen. So just ignore the code for now. Imagine it's not here. Oh, I can just delete it. It's gone. Maybe I shouldn't have done that. You might have been looking at it. I'm sorry about that. So I'm just down here at the bottom. Well, the thing that I want to point out is that there are, as you might probably imagine, there's other ways of comparing values, right? So here, for instance, we've used the greater than sign to ask if circle.x is greater than the width. We could check if circle.x is less than the width by making the angle bracket point the other way. You've just got to return to remembering some basic maths. So that's less than. I'm not going to run the program with these because most of them aren't actually going to work. You can think about why, for example, circle.x is less than width is just not going to work at all. Actually, I might do something semi-interesting. I'm not going to get distracted by it. Check it out for yourself and see what it does. We can also ask about things being greater than or equal to. So we write the greater than sign and then it's immediately followed by an equal sign. That's how we check greater than or equal to. Same thing for less than or equal to. The main thing is remember that you write the less than first and then the equals, right? You don't write the equals first. And then the other two really important ones, so that's greater than, less than, greater than or equal to, less than or equal to. If you want to check whether things are exactly equivalent, we use 3 equal signs. It seems excessive, and you will see people using 2 equal signs like this when you look on the internet, but you should always use 3. 3 is good. It's not the case that 4 is better. 4 doesn't mean anything in programming. Exactly 3 equal signs is what you should use if you want to check whether 2 things are equal to each other. So if you want to ask the question, is circle x exactly equal to width? That is what you would write here. Okay? And this means that this if statement would be true only at the exact moment that circle.x is equal to the width. You can run that and see what its behavior is as well and see if you can work out why. The other thing that we want to be able to check if we are going to check equals is we want to check if things are not equal. And here we write, this is how we say does not equal. It's a bit weird if you're not used to programming yet. We have an exclamation mark. That's an exclamation mark. And then we have 2 equal signs. So exclamation mark equals equals. This means does not equal. So this whole thing would be true if circle.x does not equal the width. And again, you can think about what effect that would have on the program if we were to run that and see if you're right by running it. Yeah. So obviously you use different symbols, these different things, greater than, less than, etc. depending on what it is that you want to accomplish. That makes sense. Oh, and I should say, just in case you care, that these things, greater than, less than, equal to, these are called relational operators, just if you want some jargon in your life. So that being said, let's throw in a couple more things into our program. I'm probably going to follow the lecture notes here, but we'll see. I just realized that I'm actually looking at the program right now. So what we have now is satisfying in that when the circle reaches the right-hand side, it reverses its speed using circle.speed equals negative circle.speed and starts heading off to the left. But if we wanted to, we could also then make it hit the left-hand side and come back towards the right. So if we wanted to do that, let's write another if statement, if. And what do we need to check here? Well, we're going to be checking the circle's x position again, so circle.x. But now we want to know, is it going off the left-hand side of the screen? So we know that the left-hand side of the screen, canvas is probably the correct, better word to use there. We know that the left-hand side of the canvas on x is at 0, right? That's the far left of the canvas. If it's going to go further to the left than that, it's going to become a negative number. So what we can ask is if circle.x is less than 0. If it's less than 0, it's gone past the left-hand edge of the canvas. And again, when we want to tell it what we want to do, we create these curly brackets immediately after the condition in its parentheses, and we tell it what to do. And actually what we can tell it to do is exactly the same thing as we told it to do before, which is to set its speed to the negative of itself. Consider that when we're checking, when we sort of most care about this thing, has it become less than 0, its speed is going to be negative at this time, right? Because it's moving to the left towards the left side. Each time through, speed is negative, it's being subtracted from the position, and the position is getting smaller. So when it does reach that point, if we set its speed to the negative of itself, well, the speed is already negative. This would be -1. And if we take the negative of -1, if you recall your mathematics, the negative of a negative number is a positive. So it would become 1 again. And if it becomes +1, then it starts moving back to the right. Let's also, while we're here, let's make it move a little faster because it's boring to watch it go so slowly, I find. So I'm going to save that and let's go look. Moves to the right, bounces off. Moves to the left, bounces off. It's kind of amazing to think that something that looks so physical and lively is really just built out of some maths expressions and decision making at the level of code, you know, just reversing speed, checking where the thing is every single frame. And what you get out of it is, at least I think, incredibly satisfying. I think it's a really neat thing to watch. Let's add something else in maybe as well so that we can and as I said maybe at the start, let's add some user input here. So the thing that's probably easiest for us to check is the mouse position. So let's say if the mouse Y, let's be racy and say mouse Y. So the mouse Y is the vertical position of the mouse in the canvas. If it's less than halfway down the canvas, height over 2, then let's set the fill of the circle to red. And if the mouse's Y is greater than height over 2, halfway down the canvas, then we'll set the fill to blue. So here we're saying if the mouse's Y position is less than half the height of the canvas. So that's saying if it's above, because less than, remember the height weirdly starts zeros at the top, so if it's less than half the height, we're talking about the top half of the canvas, then we fill with red. And if it's greater than that, i.e. it's below halfway in the canvas, then we'll set it to blue, as you probably just saw. As I move my mouse above halfway, the circle is red because that fill command is being enacted. And if I move it down below halfway, the circle is blue because the blue fill is being connected. And so we can make our circle flicker red and blue as we wish. So this is a different kind of thing that the circle is reacting to, right? This is user input that it's reacting to, so it depends on me doing something. If I just sit here, then the mouse Y is not going to change and the circle is going to stay red. Whereas because the circle moves on its own, it's constantly reacting to those checks about whether it's off the right or the left-hand side. Okay? That's that's probably enough. There's a couple more things in the lecture notes if you want to look at them. I really just want to get this basic idea of, we can say if, and then we can compare a couple of numbers, basically, right? And then if that comparison turns out to be true, circle.x, for example, is greater than width, then inside the curly brackets, inside this block of code, we can take various actions that respond to that situation. And that really is what we do with conditionals, okay? Yeah, so that's it. That's how conditionals work. As you're seeing, we're very, very frequently using in those conditions that we're checking maths, so we're comparing numbers. That's not always the case, and we'll see some other examples of other kinds of things that we might check. But this is exciting because it means that our programs can respond to things. The circle can respond to hitting the wall that is the side of the canvas. It can respond to us moving the mouse up and down. And really just any information that our program has access to is now fair game for us to respond to in our code using if statements. That is how it happens. All of the software that you see that responds to something happening, somewhere in there there's if statements going on, I assure you. Okay, that's it. See you in the next video. Enjoy your if statements. Bye. Bye. They did not stop recording.